All right, here we are, last formalized section of probability, in this case, conditional probability. And we're going to be talking about independence, trying to make sure my mic's a little bit louder, so my apologies for my mumbling in some of the later videos. Anyway, again, finishing up Statsmatics. This is Chapter 5 in the Practice of Statistics. It's Unit 4 from College Board's AP Stats course. And for those of you following along in college, it's just whatever conditional probability is. So anyways, general multiplication rule is just this. And again, as I said at the end of the last video, this is very similar to just a different form of P of B given A, okay? Excuse me. So probability of A and B is the probability of A times the fact that probability of B given A. And again, this is a conditional probability. Remember the little line between B and A stands for given that. If A and B are independent, then the probability of B given A, like we talked about earlier, is just the probability of B, because it doesn't matter if A happened or not. It has no impact on what's happening with B. And then if that's the case, then now the probability of A and B is the same as the probability of A times the probability of B. So that's helpful sometimes. If you don't know this, this will just turn out to be the same thing as probability of B. So if you have to memorize the formula, some people just stick with this and then do with it what they have to. Now, in terms of tree diagrams, you've got the probability of A and the probability of not A. Okay, and so those go off here. Now, you can do this one of two different ways, because sometimes you'll actually have multiple options here, and I'll talk about that here in a second. So you write the probabilities kind of on the little branches. Where are they going? And then the conditional probability happens down over here. So this is the probability of B happening given the fact that A happened. This happens a lot when the first probability will take options out, much like, the card draw, or if you're putting things in a hat, or socks in a sock drawer, or any of the other classic probability types of problems. Or, for example, maybe students. So like, once you pick a senior, the seniors are out, okay? Now, the reason why we have B and C down here is just to mix things up, because sometimes you have two options. So let's say, like, either you're going to pick option A or not option A, but then you still have the choice of picking option B or option C. So this could be B and B complement, much like we have A and A complement down here, but you could also have B or C. So, but remember, the whole idea of the tree diagram is that you're laying out all the different possibilities, and then if you multiply the probabilities as you go, so in this case here, probability of A times the probability of B given A, you get the probability of A and B both happening, the probability of A and C both happening, et cetera, et cetera, et cetera. Okay. And trust me, and then the last thing down here, this is probably one of the most useful, underrated types of things. The probability of at least one thing happening is the basically 1 minus the probability of nothing happening. And this complement rule down here, and that's, you can adjust it, and we'll play around with it, I believe, in the next chapter, but it's extremely helpful to find large probabilities. If this is a large probability, you basically go 1 minus the complement of whatever that probability is. All right. Pardon me. So in the 2016 election, 30 states went to vote Republican and 20 states went to vote to the Democratic candidate. Of the 30 states that went Republican, 29 were in the continental United States. That's the 48 contiguous states down here in North America, except for Alaska, Hawaii. And of the 20 states that went Democratic, 19 went 19 are in the continental United States. One state is selected at random. So the first thing that they're having you do is construct a tree diagram. So first things, since this down here says of the 30 states that went Republican, 29 were continental, this is a condition. So that has to go second. So you go down here and you're going to have states. Well, I suppose you could mix it up if you wanted to. You could say, is it continental or not to 48, but it's just easier to go this way. I distract myself, I'm sorry. So 30 and 30 out of 50 chances going up here, 20 out of 58 chances down here, boom, 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 boom. 29 out of 30, 1 out of 30, et cetera, et cetera. So when you do this, these probabilities over here. Now, I know I said earlier that you multiply it out and you don't reduce. The little asterisk by that is saying if you're going to get really crazy, stupid fractions, then, or if they're really easy to simplify, because look, the 30s divide out, the 20s divide out, please go ahead and do that. Just makes life easier. The main key is that you have all the same denominators down here at the end. It makes life easier. So 30 out of 50 times 29 out of 30 is 29 out of 50, et cetera, et cetera. So find the probability that a randomly selected state in the continental was in the continental United States and went Republican. The probability of continental and Republican, we already have that. Boom, 29 out of 50. Right as a probability. If we select 4 states at random with replacement, what's the probability that at least one of the states would be in the continental US and went Republican? This is going to be where we use this up here. So the probability that at least one of them did that means the probability that none of them did that. And the probability that none of them was US and Republican is a 42% chance over there. Okay, and so that would be actually from up here. So you would have 42 to the 4th power, because again, 42% times 42% would be the chance that both of them are, et cetera, et cetera. Away you go. And last but not least, given the random possibility that the state is not in the continental United States, what is the probability that it went Republican? So the probability that it went Republican, given the fact that it's not continental. Well, the two not continental options are down here. So those are going to be my probability down here. And then the probability that it was Republican went up here. And again, I've got the formula down there. And away you go. So that's it, basic probability. So with that being said, I will see you back in chapter 6. Talk to you soon. As always, let me know if you have any questions. Bye.